So let me write this KCL equation now. KCL at supernode 2 and 3. First current is towards left. Now here we have to be a little careful because this is the current flowing through 1 ohm resistance towards the left hand side direction. This particular current will be nothing but potential difference across 1 ohm upon resistance 1 ohm. Now what is the potential difference? You can see that it will be V2 minus V1 if this 8 volts was not there, but because this 8 volts is also there, we'll have to consider this 8 volts in the expression of the potential difference also. When the current flows towards left, the drop will be plus on the right, minus on the left. So first I write down the total voltage on the positive polarity side. 1 voltage and 8 volts is the second voltage, so it will be V2 plus 8. Now why it is V2 plus 8 and not minus 8? Because on the positive polarity side there is a positive terminal of this battery 8 volts, and because of that the total voltage on the positive polarity side will be V2 plus 8. So it becomes V2 plus 8 on one side, and on the negative polarity side there is only one voltage, which is V1, and because it's a potential difference we take the difference between the voltages on both the sides. I repeat, if we had this battery connected like this, then we would have taken V2 minus 8 minus V1 upon 1. But in this case, because positive terminal of 8 volts is at positive polarity of 1 ohm, it is V2 plus 8 minus V1 upon resistance is 1 ohm. So that's my first current. The second current is this downward current through 20 ohm resistance, so that will be V3 upon 20 because there is no battery here in this branch, and this will be equal to 0. Now this will give me V2 plus 8 minus V1 is equal to 10 plus V3 by 20 equal to 0, and hence this becomes one equation. If I simplify this in form of V2 and V3, so it is V2 plus V3 upon 20 is equal to 8 minus 10 is minus 2, goes on the other side, will be plus 2. So that's my equation number 2. Equation 1 is directly the value of V1 that we substituted here, so we got equation in the form of V2 and V3. Now we need one more equation in the form of V2 and V3. Only then I can find the values of V2 and V3. So how to get this second equation? That we are going to get from the battery that is connected between the two nodes, because we have considered the supernode in this particular case. So the third equation will be nothing but the difference between V2 and V3 being equal to 12. Now what difference we should take? Because the positive polarity of the battery is towards V2, it will be V2 minus V3 equal to 12. So that's my second equation. I would call it equation number 3. It is the second equation in the form of V2, V3. We have got two equations. Let's solve them simultaneously.